Okay, hello everybody. My name is Noam Moshe and welcome to our talk for today, a pain in the NAS, exploiting cloud connectivity to pwn your NAS devices. So a short word about myself. I'm Noam. I'm a vulnerability researcher at Clarity Team 82, and with me is Sharon Brizinov, our director of research. And of course, special thanks to the other researchers of Clarity Team 82, Vera Mens and Uri Katz, for helping us in our research. As you can see behind me, this is our lab. This is basically our playground where we get to research and look at OT and IoT devices, mainly searching for vulnerabilities on these kind of devices. So let's talk about what we're going to present to you today. During the last October, in the Pwn2Own competition in Toronto, we aimed at exploiting both NAS devices in the category, it being Western Digital PR4100 and Synology, each netting us around 40,000 K. Now, when we began our research, our main goal was trying to understand what kind of attack scenarios can we explore that were less explored by other researchers over the years. And that's when we discovered that both of these platforms actually had a NAS cloud platform. In the case of Western Digital, it being OS5 MyCloud, and in the case of Synology, QuickConnect. Now, you might be asking yourself the same question we asked ourselves: what is the main business logic of this kind of operation? And that's pretty simple. You see, I have my NAS set up either at home or at my office, and I'm out about in vacation, outside, basically somewhere around the internet. And somehow, through some kind of magic, I am able to access my files and get access to my photos, to my documents, etc., all through using the cloud application. Now, the minute we realized this is the worst case, we thought to ourselves, what could we do? And that's when we realized the coolest thing would happen is if we were able to actually access other users' files, getting access to their sensitive information, documents, etc. And during our research in the Pwn2Own competition, in the month leading to it, this is exactly the kind of vulnerability we managed to achieve, gaining access to millions of files on thousands of different devices all around the world. After we gain access to this file, we asked if the most important stuff, getting access to files is pretty cool, but what would be cooler, and that is pretty obvious, actually exploiting code and running arbitrary code on the platform. And that is exactly the kind of vulnerability we managed to achieve during the Pwn2Own competition by changing 5 different bugs that we're going to present to you today. However, because we actually use the cloud platforms, we had the ability to not attack only one NAS, but instead attacking every single NAS that is connected around the world, giving us access to thousands and actually millions of different NAS devices. Well, that is pretty huge, and today, in order to remediate our vulnerabilities, Western Digital actually had to boot off devices running old firmware from the cloud, meaning they are no longer able to access the cloud in running old firmware, and they have to update. This is because our and other researchers' security vulnerability research, where we found vulnerabilities so critical that we actually had to be booted off the cloud platform. This is the kind of research we conducted, and today I'm going to try and relay it to you, showcasing the entire research process we've performed. So let's deep dive. What is Western Digital PR4100? It is actually a Linux-based NAS device running custom Linux architecture and exposing multiple different services. Of course, a web management service allowing administrators to set up their device, as well as file sharing like SMB, FTP, and of course, web access. When we tried and ordered our device, the first thing we did was simply order it. However, I'm pretty impatient. So I thought to myself, while waiting for the device to arrive, I'll try and emulate it. Luckily for me, Western Digital offers this device firmware in their cloud services, just meaning I was able to simply download it and access the files. Usually when I access files, and specifically firmware, it is a huge binary blob, meaning it is composed of multiple different sections, each composing of, for example, libraries, different binaries, etc. And of course, it could be either encrypted or unencrypted. Luckily for us, Western Digital chose to not encrypt their firmware, meaning we simply could use binwalk to cut the firmware into different sections, giving us access to both the libraries, binaries, and of course, configuration files. However, simply having this kind of structure does not mean we have a working NAS, so we had to somehow reconstruct the file system, rebuilding the NAS device. Once again, we got pretty lucky, and Western Digital actually left some files in their firmware that were meant to reconstruct the firmware from the different sections. Meaning by simply using truth on our own virtual machine, we were able to rebuild the file system and execute the different daemons, specifically the HTTP daemons. And now we had access to a NAS device. That is pretty cool because usually when I work on devices, I tend to break them. And my boss, he gets pretty mad at me because we need to simply order a new device. And now I have a simple playground that I can do whatever I want to and simply boot up my own device anytime. So basically, after we managed to root the device, we had the ability to run the different binaries, and we now had a working web services for our own emulated NAS device. And our goal was to start digging in and trying to realize what is the different services that are running on this NAS device. Now, this is the main platform of the management server for the NAS device. And actually, when we did our preparations for Pwn2Own, we looked at all vulnerabilities that different researchers looked in the past, and most of these vulnerabilities were involving this web management architecture, specifically in the different PHP files and CGI scripts. So in order to remediate it, Western Digital chose to implement a new binary called nasadmin. This is written in Golang, and now this is the actual entry point to the web server. This binary basically handles the different authentication and authorization for our NAS device, making sure every request is validated and has a proper user session. Sadly for us, in Pwn2Own, the rule says that we must achieve remote code execution unauthenticated, meaning we have no access to different kind of users. So because we couldn't bypass the nasadmin authentication, even though we find some vulnerabilities in the PHP server, it was not useful for our Pwn2Own exploitation. And that is when we turned our heads into the cloud feature, which is the main vulnerabilities we found is located at. You see, when I boot up my NAS device, I'm able to simply turn on the cloud access, and by creating my own user, I'm able to now access my NAS from anywhere around the world using either a web-based web browser or, of course, a mobile application. And when I try to access my files, somehow, through some kind of magic, I am able to access it. And we thought to ourselves, how the hell does this happen? Well, you see, whenever I try and access my files, I authenticate to Western Digital's different web services, and I'm authenticated to my own account. To my account, is associated my NAS device that is identified by a different GUID that is unique per NAS device. And then whenever I try and access my device, I simply fetch a URL, an API URL, specifying my device's GUID. And then in the background, somehow the cloud application matches my GUID to my NAS and routes my request to my NAS. When we realize this is the architecture, and through this GUID we are able to access our device, we thought to ourselves, what could be pretty cool? And of course, the obvious question is, what would happen if an unauthenticated attacker not associated with my NAS would be able to know my NAS's GUID somehow and access my device through the Western Digital's proper API? And we actually tried doing this pretty early on, and sadly, we got blocked, which is pretty sad. However, because it was our own device, we were able to set up Wireshark, or TCP dump more specifically, and we noticed that a new connection was made to our NAS. Meaning, through knowing the device's GUID, we managed to access our NAS. However, what's crazy is that the request we made, that was made to our NAS, was made over Western Digital's cloud, meaning my NAS was not internet exposed. It doesn't have an exposed IP address or port forwarding of some sort, meaning we actually reached our own home network through the cloud. And that is pretty crazy because we don't see a lot of NAT bypasses through this kind of reverse proxy that somehow happens. And that's when we realized what our goal should be. You see, all we need to do is to somehow guess the device's GUID, find an auth bypass, meaning, yeah, we can reach the device, but we need to be authenticated and somehow bypass the authentication requirements, and of course, change some other vulnerabilities to achieve remote code execution. And when we realized this is our goal, we said, yeah, this looked pretty easy. Let's see how we did it. So this is the main use case of our device, meaning I am sitting somewhere around the world and I'm trying to access my NAS through the cloud application. However, there is one use case that Western Digital actually implemented a specific user experience ability, and that is whenever I'm trying to access my NAS when I'm at LAN at home. You see, if I were able to fetch a file, let's say a movie or a picture that is pretty big, if I were able to do it over Western Digital's cloud servers, it will be pretty slow and pretty ineffective. So instead, whenever I'm sitting at home with in the same network that my NAS device is located at, I am redirected to my NAS device that is sitting with me. And then I'm fetching the actual files over the LAN connection, which is way faster. However, Western Digital had to make sure that I'm actually accessing my device and not some kind of attacker, for example. And in order to do that, they actually issued a unique certificate for each device. And that way, whenever I'm trying to access my device, I can make sure it is actually my device because it has a unique certificate issued by Western Digital. However, the keen-eyed in you probably noticed something weird. You see this? This is actually our device's GUID embedded into the certificate. Meaning, by simply accessing our device over HTTPS, we are able to get the device's GUID. And now we can access it over the cloud. Now, on its own, it's not that big of a deal because we still need direct access to the NAS HTTPS server. However, maybe we can somehow improve it. That's when we try to realize, wait, how the hell does this redirect work? How am I redirected to my NAS? Actually, behind the scenes, I am redirected to a DNS name that is mapped to my device, and the DNS is actually converted to the LAN IP of my device. Meaning, if I were able to NS lookup to translate the DNS name, I would get the internal IP address of my device. And that way, whenever Western Digital tries to redirect me, it simply tells me, hey, fetch this file, and by translating it to the LAN IP, I'm able to access my file. Well, because of this DNS record, we were able to use something called passive DNS. You see, some DNS servers actually sell the records, the metadata of the requests, and simply sell it to different API vendors that allow us to use their server's API to query all DNS records. And by using this passive DNS, we were able to get access to the DNS name of thousands of different devices. As you can see, over 10,000. Well, we actually did this, and it was pretty cool, and we got access to thousands and thousands of these devices. However, almost all of them were dead, meaning they were no longer accessible either because they disconnected, they got reinstalled, etc. Their GUID was changed, and we could no longer access them. So we thought to ourselves, yeah, let's improve it once again. That's when we turned our heads into certificate harvesting. Like I've told you before, each device is issued a certificate that contains the device's GUID. So by simply using servers that hold the records of thousands, and in the case of Tenzis, actually billions of different certificates, and querying them using their API, looking for Western Digital pattern, we were able to get access to millions of different devices. As you can see, just by using Tenzis, we were able to get access to 1.5 million certificates in just the last 3 months, meaning they were for sure activated and still accessible. Well, that was pretty cool, but for the Pwn2Own competition, we had to actually attack the device in real time. So our goal was to, from getting access to millions of devices, our goal was to leak the GUID in real time whenever it connects. And that's when we thought to ourselves, how can we somehow keep track of different certificates being issued? Well, turns out the answer to this request was CTL. For those of you who are not informed of CTL, it is actually a specification in the internet that its main goal is to improve internet security. And basically the gist of it is that whenever a CA issues a new certificate, they send a metadata feed about this certificate, mainly the certificate name, who requested it, etc., into the CTL feed, allowing users to subscribe to it and get notification of every single certificate being issued. Well, by simply subscribing to the CTL feed using different open source tools, we were able to grab into Western Digital's pattern and get devices in real time, meaning we had access to the ability to get the device's GUID whenever it was issued. By subscribing to CTL for a few hours and a few days, we actually got thousands and thousands of these devices, meaning we now had access to all of the devices' GUIDs the minute they are issued. And once again, through Western Digital's cloud, we were able to access them over the cloud. Okay, so we now had access to millions of devices. However, our next step was actually find an authentication bypass, meaning we are able to access the devices. However, our goal is actually fetching and you doing some API requests. That's when we simply asked a very generous person in our company, hey, does someone have a device we can use because we want to test a few things? With the promise not breaking the device, we actually got access from to a friend's device. And we did, once again, the obvious and naive approach, meaning we simply took the request we performed to our NAS and changed the GUID. And whenever we changed the GUID, we started monitoring what kind of API endpoint returns actual results and not. And pretty soon, we found a combination of API endpoints that simply worked. This means that these endpoints checked for our authentication and not authorization, meaning by just having a valid session cookie to our own device, we were able to access other devices, meaning we now had access to all of the devices around the world, giving us access to everyone's file. Now, this was pretty cool, and we turned our head into achieving remote code execution of these devices. However, sadly, a few weeks before the Pwn2Own competition, we tried our scripts and our exploits. And these exploits worked in the past, however, we tried them before the execution, and they simply did not work. This was heartbreaking for me because the research I've done in the last few months simply was fixed on Western Digital's endpoints, and now all of the API routes we found that did not check for proper authorization did. Somehow Western Digital just simply pushed a patch that fixed our vulnerabilities. That's when we turned our head and said, okay, we're gonna find the new vulnerabilities and get access to everyone's files once again. So let's take a look at the main cloud binary that handles most of the authentication and cloud APIs and see what it does behind the scenes. This binary is called REST SDK, and it is the main cloud binary that handles most of the different functionality, both validating users' tokens and, of course, fetching and writing files like you get from the cloud API endpoint. This binary, once again, is written in Golang, which is actually pretty hard because Golang offers a lot of built-in security. For example, we have no memory corruptions in Golang. We cannot look for them because Golang handles most of the memory allocations. And of course, a lot of the APIs, for example, performing an OS command is done safely, meaning unless a developer really wanted to put a vulnerability in this API endpoint, it's probably safe. So in order to understand what's happening behind the scene, we had to try and reverse engineer this binary and somehow know what it's doing behind the scenes. Well, through the process of man-in-the-middling the entire cloud tunnel creation, our goal was man-in-the-middling different HTTP and HTTPS requests our NAS device performs in order to better understand how the hell does this tunnel creation magic happens. How am I routed to my device whenever I try to access my device's GUID? And by achieving man-in-the-middle, we were able to actually view every different request performed that is done by our NAS device, meaning we had the ability to view it and better understand the cloud creation process. Well, let me summarize it for you. Basically, whenever our device tries to connect to Western Digital's cloud, it opens a TLS connection to one of Western Digital's proxy servers. And whenever it opens the TLS connection, Western Digital's proxy servers perform an HTTP2 request to our device saying, hey, I'd like to proxy connect to you, meaning I'd like to open a tunnel. Well, to this question, to this query, API request, our device says, yeah, sure, I'd like to connect to you. Here is my device's GUID. And Western Digital takes this GUID and actually establishes the tunnel, meaning now whenever a user tries to connect to the device, specifying this GUID, it gets connected to our device. Now, the minute we saw this kind of authentication, we said to ourselves, wait, what? Where the hell are the secrets? This is proper device authentication. Through this channel, our device authenticates to Western Digital's cloud, saying, yeah, whenever a user tries to access their device, route it to us. However, once again, no secrets were used, meaning no passwords, no secrets, no API keys, certificates, nothing. The only knowledge that was required to create a new tunnel to the Western Digital servers was the device's GUID. And like I've shown you before, it is public knowledge. All you need to do is access the device GPS port, and you are able to view the device's GUID. So we did the pretty obvious thing and simply implemented this on our own. Meaning we connected to Western Digital servers and said, yeah, I'm the GUID. And whenever we did it, Western Digital said, yeah, sure, I trust you, hello, device. And actually disconnected the real device. Meaning whenever a user tries to access their device, it is now routed to us. That is actually pretty crazy when you're thinking about it, because that way we were able to impersonate the device and route requests to us. However, what was even crazier was what happened next. Because whenever our tunnel was established, immediately we got this. And as you can see, this is a valid user request containing the user authorization token. Whenever we saw that, we were pretty stumped, saying, wait, how the hell did we get a session? How the hell did we get a token? However, after a short realization, we realized that in order to keep the device up to date, the cloud application constantly performs background app refresh, meaning it constantly tries to reconnect to the device and stay up to date, checking if some kinds of files were changed or if something was changed. And in order to improve the user experience, the cloud application, the actually user application, constantly performs requests to the NAS. And because we impersonated the NAS, we now had access to these requests, giving us, once again, access to everyone's files. Cool. So next up, after we had access to these files, our next goal was to actually find an RCE and somehow exploit these devices.
Wow, that's pretty crazy. Not only we had access to all the GUIDs of all Western Digital cloud-connected devices, we could also abuse our authentication bypass to impersonate the device and then get the user token. We now had the ability to get user tokens. So basically, we had now new attack vector, which is authenticated user, and we could explore more API. Now, sadly for us, having admin access to a device does not mean remote code execution, right? So we have a fully authenticated session because we stole one, but now we had to change some more vulnerabilities on our new attack surface, which is authenticated user, and chain everything together to get pre-authenticated remote code execution. Now, to achieve this, we had to reverse engineer a bit more the REST SDK, but now we weren't focusing on the pre-auth routes and APIs. We focused on the authenticated routes because we had a valid session, we had a valid user. So we started to explore all the available APIs and basically everything that a user can do on their devices through normal activity like logging in to the application through mobile or through the web and playing with it. For example, a user can shut down their devices remotely. So this is an API that goes through the REST SDK, and this is, again, one of the functionality we researched now as an authenticated user. One very interesting feature we noticed very early is the ability to create shares and mounts. So obviously, we're talking about NAS device, and the most important capability of a NAS device is to present to you an interface that you can interact with files on your NAS through the network. So obviously, it will present to you in some kind of a graphical way all the files that you can read and write, and these files are correlated somehow to hard drives on your NAS. And the way that it happens in Western Digital is mounts and share points. So basically, each directory that you see in the mobile application or the web interface is a symlink to a directory on your NAS. So the file system maps this directory to a directory on the hard drive, and then you can read and write files to this directory. So we asked ourselves, what happens if we, in some way, find a way to change this mounting point? For example, add new hard drive, but instead of adding new hard drive, just point a real directory to /temp or to /. Will we be able to read all the files there? So we tried this. We had an authenticated user, so we tried to create new mounting point through this undocumented API. And we pointed the directory privpix, for example, to /temp. And suddenly we saw in the mobile application all the directories and all the files we had in /temp. So we could not only read the files from /temp, we could also write files to /temp. And this is pretty crazy because now we had authenticated user with capabilities to read and write files from within the file system. However, it wasn't that easy because the file system in most places was read-only. So we were very limited to where we could write files. And eventually, we chose to write files into /temp because we found another vulnerability that we were able to chain with. The next route we considered is the reboot one. I already told you that any user, authenticated user, has the ability to reboot their devices remotely through the API. And so we researched the binary that is responsible for this behind the scene. This binary is called do-reboot, and it has very simple logic to reboot the device using the Linux API. But behind the scene, it does all kind of logging mechanisms and reading other files that we thought we should explore. One of the things we noticed really on in the process of do-reboot binary is that it reads a file from /temp, parses it in some way, and then uses it in a system command. So we basically found an injection point to this system command, which will get executed. So what we thought ourselves is, what happens if we use the previous vulnerability to create new mounting point to /temp, write our file that will be parsed in some way that will get our code execution. So this is exactly what we did, and now we had our chain completed. So by using the device GUI that we were able to leak through multiple ways, from Census certificate servers to CTLs, we're able to impersonate the device, get the user token, achieve authenticated attack surface, and then create new mounting point to write our files to /temp, write a file that will be parsed with an injection point, and get RC. So let's see how it looks. The full exploit chain looks like this. First of all, there is a user that is connected to their device. They have their own GUID. Next, we come up and we say we want to attack this device. And we know the GUID because, as Noam mentioned, this is kind of a public knowledge. We can query it from the certificate. Now, we're telling the cloud platform, hey, we're the real GUID. We don't know who the other device is. So basically, we're impersonating the device. And since there was a bug in the cloud that did not check anything else besides the GUID, it fully trusted us and disconnected the real tunnel. So once we were connected as impersonated as the device, we immediately got the request from the user who just wanted to access their files. And it happens automatically immediately. And so now we have the user authentication token. So we can wait a few minutes for the real tunnel to come up. Again, it happens automatically. And then we're using the token as if we were the user. So now we're impersonating the user to connect to the real NAS. Now we have an authenticated attack surface. So we're creating a new mounting point to /temp, so we could interact with files, read and write files from /temp. We are writing our file that will be the injection point, and we're activating the do reboot process. And once this happened, we get command execution on the NAS, and we get our shell. And this is exactly what we did in Pwn2Own and got 40K. Now, this was a concept that we developed to impersonate a NAS device, and we did it with Western Digital. But we also were able to do the same for Synology device. So let's take a quick look on the same concept with Synology. So for Synology, we had to research the Synology DS920. This is a very popular NAS. I have one at home, actually. It's a 86 architecture with 64-bit, and it has a very fully featured web-based, and behind the scene, it runs C++, CGIs with Nginx. Once again, this device, this NAS, had a cloud connectivity platform. The cloud connectivity platform of Synology is called Quick Connect. And once again, if you want to reach your device at home while you're at work, for example, you can go to quickconnect.to or to the mobile application and connect to your device. Obviously, the first thing that you need to do is to associate your Synology user with this device. So we can go to the NAS web settings and configure the alias for your device and associate the user. So basically, anyone can choose any alias they want. It's like a username for their device. If it's not taken before, you can have any alias that you want. So how it works, once again, we have the mobile application or the web Quick Connect website, and we're sending a GET request to your alias.quickconnect.to, and you're reaching to the device. Now, behind the scene, what happens is once the Quick Connect cloud receives this request, it will issue a open tunnel using OpenVPN request to the device, meaning the cloud will tell the device, hey, start a VPN connection with me, which the device will gladly do. And now we will have a full tunnel that Quick Connect relays everything to the device through the VPN connection. Now, if you noticed, once again, we had a DNS, a subdomain. So we could query, again, all the aliases of all Synology devices across the globe, because using passive DNS records is very easy to get all the subdomains of all the devices. So we wanted to understand the second part. We wanted to understand, again, we had a concept of impersonating NAS devices and leveraging this into RCE. So we wanted to explore what happens and how it happens that the device is opening a connection with the Quick Connect cloud. And obviously, the bug in Western Digital is that the secrets that the device used to connect to the cloud were mainly the GUID, which is obviously not enough. So we wanted to understand here, what are the secrets, what are the tokens, what are the digital elements that the device is using in order to connect to the cloud. And this is exactly what we researched. We researched this process of what secrets are transferred to the cloud and how the cloud is transferring back to the device, the OpenVPN configuration. And it was a long process because it was a very complicated process that we researched for a long time, but we can summarize all the digital elements, all the secrets that we need into a list. And it includes, obviously, the MAC address of the device, the serial number, the device module, and a couple of API keys that are transferred to the device in the first place when the user authenticates and associates their accounts on the device. So we started to research and we started to understand how can we leak these secrets or tokens. The first thing is that we saw that the MAC serial and the device module are pretty easy to achieve because Synology has this protocol, Synology Discovery Protocol over UDP 999. And actually, they're using this in a legitimate way in their Synology Assistant Discovery. So whenever you buy a new device, you can plug it into your network. You don't know the details of it, so you can run the discovery and see it. And the magic behind it is Discovery Protocol, or specifically discovery packets that are being sent across the network as broadcast. And if the device receives them, it will reply with all the details. So that was perfect for us because now we had the MAC address, the serial, and the device module. We also had to calculate something called the DS token, which is kind of a MD5 routine on the serial. So we had all these basic stuff, but now we had to get the API key, which is the device token that is used to connect to the cloud. Obviously, it's not straightforward to get this because this only happens when a user associates their account on the device in the first time. But we were able to find a bug in their cloud platform, specifically in one of the routes, that allowed us to register new API key on behalf of the device only if we know the serial and the MAC of the device. This is crazy because now we could generate ourselves a valid API token, and it did not even invalidate the previous ones. So the device kept working, and it was not even aware of it. Great, so now we had the API key, and now we needed to get something called the authentication key, which is a user token that is associated with the device. But once again, we were able to find another vulnerability that allowed us to generate authentication key based on the previous elements we had. So we could use the API key that we generated for ourselves, and we could use the serial and the MAC. And now we had the authentication key and basically all the elements that we needed in order to fully impersonate a device. So now we could tell the cloud service, hey, we're the device with this serial and MAC. Please change this and that configuration. So we could impersonate the device. Now, what we did is we actually impersonated the device and then told the cloud platform, hey, we changed our IP address, external IP address, from the current one to 1234. And then we set up our trap on 1234. So whenever the user wanted to access their device, the cloud relayed in not to the real device, but to our trap on the IP 1234. This was perfect because we could impersonate the device and on behalf of it, change the IP address. So what we did is exactly like previously, we relayed users, real users, instead of their devices to our trap. We got their token, and then we used it to connect to the real device and execute code on it. So this is exactly, again, what we did in Pwn2Own, and we got $40K for it. So just to give you a quick summary of what we did. Users want to get to their devices, obviously. But because of a couple of vulnerabilities we found both in Western Digital and Synology, we were able to redirect users to our impersonated device. Now, whenever they got to our device, they handed us their tokens, and we used these tokens to access their real device and leverage vulnerabilities on the device to get code execution. Now, the real problem with this is that cloud services focus on strong user authentication, but not so much on device authentication. So weak or public knowledge identification are used for, we found that weak or public knowledge identification were used for device authentication, which enabled us to impersonate devices and trick users to give us their authentication tokens, and we leveraged them into remote code execution. So thank you very much, and we hope you enjoyed it.
Yeah, if anyone has any questions, now is a great time to ask us, or you can go to the wrap room later on.
Yep.
And contact us directly. Thank you very much, everyone.
Thank you.